Alright, picture this. You're floating through space, minding your own business, maybe sipping on some zero-gravity coffee, when suddenly, boom, a black hole appears out of nowhere. Your spaceship's alarms start blaring, things are getting weird, and before you can even finish your coffee, you're spaghettified into a stream of atoms. Yeah. Black holes don't play fair. But here's the real kicker. Black holes don't just break spaceships. They break the actual universe. Like, fundamentally. As in, physics itself looks at black holes and says, yeah, I have no idea what's happening here. And that's what we're talking about today. Why black holes are cosmic rule breakers and how they mess up everything we think we know about reality. Step 1. Black holes are already a problem. First, let's talk about what a black hole even is. Because despite their name, they are not holes. If anything, black holes are the opposite of a hole. They're like the most obnoxiously dense, gravity-crushing objects in the universe. Imagine if you could take the entire Earth and squish it down to the size of a marble. Congratulations, you just made a mini black hole. Now take something like a star way bigger than the sun, let it collapse under its own weight, and what do you get? A cosmic vacuum cleaner that eats everything and lets nothing escape. Not even light. And here's where things start to break down. Because the moment you cross the event horizon, aka the point of no return, physics just stops making sense. Step 2. The laws of physics freak out. Let's say you're brave or incredibly reckless and decide to jump into a black hole. From the outside, something weird happens. To everyone watching, you slow down. Like really slow down. Time dilates so much that, from their perspective, you never actually fall in, you just freeze at the edge, stretched out like a weird hologram. But from your perspective, oh, you're falling. And the moment you cross the event horizon, time speeds up dramatically. The universe outside seems to rush forward. Stars are being born and dying in seconds. The end of time itself might play out before your eyes. And then, of course, you hit the singularity. Which brings us to problem number 1. The singularity doesn't make sense. The singularity is where all the mass of a black hole is crushed into a single, infinitely small point. But physics does not like infinities. Whenever we get an infinity in an equation, it's basically the universe's way of saying, something is definitely wrong. And yet, black holes seem to have them built in. Step 3. Black holes erase information, which shouldn't be possible. Alright, let's say you didn't just jump into the black hole, you also threw in a book. Let's make it a good one. Say, a copy of The Hitchhiker's Guide to the Galaxy. You toss it in, and as far as we know, that information is gone. Like permanently. This is not supposed to happen. Physics has this rule called information conservation, which basically says, the universe doesn't delete stuff. Information can be scrambled, transformed, or shredded into tiny pieces, but it can always, in theory, be put back together. Black holes don't care. They seem to just swallow information and never give it back. This is known as the black hole information paradox, and it's one of the biggest unsolved problems in physics. Some theories suggest that the information isn't really lost, that it's somehow encoded on the event horizon like a giant cosmic hologram. Others say it might get spit back out when the black hole evaporates. Yeah, black holes do that. Slowly. But here's where things get even crazier. Step 4. Black holes might be connected to the end of the universe. Let's talk about Hawking radiation. Stephen Hawking discovered that black holes aren't totally black. They actually leak energy over time. And if they leak energy, they must eventually evaporate completely. That means that one day, after trillions of years, every black hole in the universe might just vanish. And if black holes hold the secrets to reality, like where all that information went, what happens when they disappear? Do they trigger some kind of cosmic reset? Do they rewrite the laws of physics? Or do we finally realize that we never actually understood how reality works in the first place? Final thought. Black holes are cosmic rule breakers. Here's the takeaway. Black holes do not respect the rules of the universe. They create infinities where there shouldn't be any. They erase information when physics says that's impossible. They distort time and space so much that even reality itself gets confused. And the scariest part? We still don't know what happens inside them. Maybe they hold the key to understanding quantum gravity, the ultimate theory that unites Einstein's relativity with quantum mechanics. Or maybe they're portals to other universes, as some physicists suggest. Either way, one thing's for sure. Black holes aren't just mysterious. They're broken. And if we ever hope to fully understand them, we might have to break everything we thought we knew about the universe. If you enjoyed this wild thought experiment, don't forget to like, subscribe, and hit that notification bell so you don't miss the next deep dive into absurd science. Thanks for watching, and I'll see you next time.